Algebra 1, section 4-5. Scatter plots and lines of fit. All right, here's a term, bivariate data. So this is a term you might see, bivariate data. It just means data with two variables. Like our coordinate points, or coordinate pair, x and y. There are two pieces of data here that go together here, x and y. So this is bivariate data. And then a scatter plot. Scatter plot shows the data. Shows the data. All right, so we're going to look at what three versions of what a scatter plot might look like. So usually, so we have an x and y axis, x and y, and we have a bunch of data. We'll say that we have these points that kind of go like this. And so we can see that the data tends to go this direction from left to right. It goes up like that. And so this data has a positive correlation. Meaning as you go to the right with your whatever your x is, that your y value goes up. So it's positive. From left to right, it goes up. It might be like the time you drive gets you farther and farther away. So x could be your time and y could be how far away you get. So that would have a positive correlation. And now x and y again. And this we're going to show a negative correlation. Negative. And this is when my data goes like this, something like this, where from left to right it goes down. And so that could be over time a ball is dropped. And so over time the ball gets closer and closer to the ground. They wouldn't be all scattered like this, but that's, you know, you get the idea. And last one, x and y. This one is no correlation. Let's see what no correlation looks like. It might just be stuff scattered, data just all over the place. And you can't see any kind of pattern. This one obviously goes up. This one obviously goes down. This one doesn't really have an obvious trend. So let's keep going on here. We just have one example, this line of fit. We're just going to do one. I don't think we need to do a bunch. So we have a chart like this, years since 1988. All right. And so that's going to be our x value, our years since 1988. Whenever you see a graph like this, usually the top one is x and the bottom one is y. Even though we talk about rise over run, y over x, the reason x is on the top is because that's the input and y is the output. So you've got to switch it if you're looking for the slope when you're all done. If you're looking for slope, we're not looking for slope here, although we might in a little bit, but not right at first. And then we've got a vertical drop. In feet. So this might be how low some body of water gets or something like that. So we've got 1 year since '88, we've got 3 years, 5 years, 8 years, 12 years, and looks like there have been multiple measurements at 12 years, and then 13, and then 15. Right, so we've got 3 12s, then 13, and then 15. Okay, in year 1, the vertical drop was 151 feet. In year 3, it was 155 feet. In year 5, it was 225 feet. Year 8, it was 230 feet. In the first year, 12, 306, then 300, then 255. And then 13 is 255, and then 15 is 400. Yikes. Okay, so now we have all this data here, and we're going to just put it on, we're going to plot all of these points. And so we're going to separate this up into 50s. So we'll go 50, 100, 150, 200, 250, 300, 350, 400. So let's mark those off. 50, 100, 150, 200, 250, 300, 350, and 400. And then let's do years on the x-axis. So let's do years by 2s, all right? So let's go 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14, 16. All right, so now we are going to, we're going to just draw some light lines here. And we'll draw them the other way too. Okay, so now we got this graph here. We got this chart ready to go. So at 1 year, we have 151. So I'm going to put a dot right there at 1 year, 151. And then we've got one at 3, 155. So here at 3, 155, that's pretty close to 150. At 5, 225, 5, 225, that's halfway from 200 to 250. Year 8, 230, 8, 230, just a little bit lower than 250. Year 12, we've got 306, so just around 300. We've got 300, 306, and 255. So 250, 255 is right there. Okay, and then 13, we've got 255 again. And at 15, we've got 400. 15 all the way up to 400. So first we can decide, let's look at this scatter plot here. Let's decide, is this a positive correlation, a negative correlation, or no correlation? So when I'm looking at these points, I can see that generally they're kind of grouped together going from left to right up. So this is a positive correlation. All right, so I've got a positive correlation. And now I want a line of fit. So I'm going to choose 2 points, and I'm going to write an equation for the line that I feel like is the best line of fit here. So I'm going to choose 2 points. So my line is going to look, I'm going to draw like a light line here. That line looks like it kind of averages all of those points out. So I'm going to choose this point here and this point here. So there's my line. And I'm going to choose these 2 points. So this one is 151. So 151. And my other point is right here, 12 to 255. 12, or is that 12? 12, 300. Let's do that one. 12, 300. Okay, so those are the 2 points I'm going to use. And I want to write this in slope-intercept form. So y equals mx plus b. x1, y1, x2, y2. So this is going to give me my y-intercept, or I'm going to get my slope first, actually, and then I'll go for my y-intercept. So remember, slope is, oops, not y equals. My slope is m equals y2 minus y1 over x2 minus x1. So y2 is 300 minus y1, which is 151, over x2, which is 12, minus x1, which is 1. So 300 minus 151 is 149 over 12 minus 11, 12 minus 1, which is 11. Okay, so 149 divided by 11, ew, gross. 149 divided by 11 is 13 and a half. Oh, last time I picked much better numbers. Okay. Let's see, 13 and a half, gross. Let's just do that. 13 and a half is approximately 13 and a half. Okay. So now what I do is I take my y equals my slope, which is 13.5, x plus b. Now I just need to solve for b. So how do I solve for b? I just choose an x. I just choose one of these guys to plug in my x value and my y value. I'm going to do this one. So y is 151 equals 13.5 times my x value, which is 1, plus b. 13.5 times 1 is just 13.5, so I'm going to subtract 13.5 from each side. 151 minus 13.5 is 1, I'm having trouble doing that right now in my head, minus 151 minus 13.5, 137.5 equals b. So my line of fit is y equals 13, or my equation of the best line of fit here is 13.5x plus 137.5. And so I can look at my chart here and I can see, does this make sense? So here it's my y-intercept is 137.5. Does it look like this line could cross at 137.5? I guess so, maybe, right? It's a little under 150, so that'd be okay. And you know, this drawing is not awesome. And then 13.5, that would be up 13.5 to the right 1. And since these markings are the way that they are, yeah, that makes sense. Up 13.5 to the right 1. That makes sense. So that looks fine. So I will go with that answer. And that is all that we are going to do for the notes for scatter plots and lines of fit. Do a good job on your homework.